This video is for section 7.6. It's on sine and cosine ratios. So last section we talked about tangent, where we could find the length of a leg if we had a leg and an acute angle. In this one, we want to find this missing side, and notice how this is the hypotenuse of a right triangle. You can't use tangent to solve that, but what you could do is use tangent to solve for this side, and call it y. And once you have this side, you could take this side and calculate this side in the Pythagorean theorem. So you could use tangent and the Pythagorean theorem to find this if this is all you knew. But what we're going to show you today is how to find this directly, and that's using different trig functions. So in your calculator, you have the tangent button. Directly to the left are two buttons, sine and cosine. Those buttons help you find the length of that x. And it'll do it directly instead of doing two different things. So we're going to apply the sine and cosine ratios. Sine and cosine ratios are trig ratios. That's when you have the acute angles and they involve the lengths of a leg and the hypotenuse of a right triangle. So depending on which acute angle you have and which leg you have to use, depends on whether you use sine or cosine, because it could be the adjacent leg or the opposite leg. So here's how they're defined. Sine of an acute angle A is your opposite leg divided by your hypotenuse. Cosine of A is the adjacent leg over the hypotenuse. Really useful trick. It's a little mnemonic device to help you remember sine, cosine, and tangent and how they're defined is this. So, ka, toa. This means sine is defined as the opposite leg over the hypotenuse. Cosine is defined as the adjacent leg over the hypotenuse. Tangent is the opposite leg over the adjacent leg. Let's write sine and cosine ratios. We want the sine of angle T. Angle T belongs to this triangle. It's an acute angle. Sine, remember, is opposite over hypotenuse. So I'll just write that out just to help you. Now, in relation to angle T, which leg is opposite? The 4. What's the hypotenuse? 5. Sine of angle T is 4/5. Sine of angle U. Remember, sine is still opposite over hypotenuse. But it's not going to be 4/5, because if you're changing acute angles, now your opposite leg has the length of 3. Your hypotenuse is still 5. So this is your answer here. This is your answer here. If you compare those two, obviously you can see some similarities. The denominators are both 5. The numerators are the different leg lengths. Let's switch it up and find cosine. Cosine is adjacent over hypotenuse. We're talking about angle T. So here's angle T. Adjacent, hypotenuse. Cosine of the other acute angle, it's still adjacent over hypotenuse. But when you switch acute angles, you end up switching legs. So your adjacent this time is 4. So if we stop and compare again, notice how the sine of an acute angle is 3/5. The cosine of the other acute angle is also 3/5. Same thing up here. Sine of an acute angle is 4/5. Cosine of the other acute angle is also 4/5. Okay, let's do these last 4 here using this triangle. Sine of angle J. Here's J. Sine is opposite over hypotenuse. So it's 24/25. Now I automatically know that the cosine of the other acute angle is going to match this. So if I wanted to, I could come down here and I could say cosine of k is 24/25. Sine of angle k, k is this angle. Sine is opposite over hypotenuse, so it's 7/25. Again, I know that cosine of the other acute angle is going to match, so it's also 7/25. Let's go over it though. Here's angle J. Cosine is adjacent over hypotenuse. So that makes sense. Sine and cosine ratios. Now that you know how they're defined, you're going to solve for whatever's missing the same way you did with tangent. So there'll be less teaching with these videos and maybe more practice, or maybe even less practice because you really should already have those reps.